In the next, let's talk about the causal Markov framework. By the way, if you have heard of the definition of Bayesian network, which is exactly based on the Markov condition, then I think the ideas we're talking about here might give another interpretation, especially from the causation point of view. And this might help us better connect to some famous notions such as the separation. Okay, but anyway, that's a bit digression. Let's go continue. So when we are talking about the Markovian property, there's no reason to stop talking about conditional independence. And, and let me show you the story. Suppose I'm a plumber and my daily work is to fix the pipe. And one of the important process about this work is to check out the direction of the flow of the water. And I'm going to do this by turning off the valve and checking the meter, and if it shows that there's no sign about the water passing through the pipe, then I can determine the water direction is from the left side to the right side quite directly, right? But if for another situation, if the flow of water just goes like this, then I couldn't turn off the valve, because this time it might be a bit dangerous, right? Because as you're seeing here, two flows of water just they're colliding with each other, right? And may I have your attention here? This structure, this junction in the pipe is sort of like a collider. And we'll mention this word in the following when we are seeing in the perspective of causal diagrams. All right. But notice that this approach just does not fit into all the situation. For example, if I have a situation where the water goes like this, or this, or this one, then no matter for which of three of this situation, I just couldn't determine the direction, because after I turn off the valve, the situation will be all the same. There's no water passing through the pipe, right? So I'm not sure here you got a sense about what we have mentioned before. That is the equivalence. So the situation is roughly the same, but we just couldn't determine those similar situations. Though we have some property to those normally we have some property to distinguish this different situation. Okay, so the moral of this story is to simply take the flow of water as the flow of causal dependence, and this is where the Markovian property will function. So next, let's go to see the causal diagram. Suppose we have the simple diagram goes like this, and let's just control the middle node here. By the way, you can just see the arrows in the diagram as kind of the flow of causal information passing through the causal diagram. And if you control the middle one, just as I shown here, then it's sort of making the information stuck at that point, and it will finally leading to the independence of these two different groups. So to give you a big picture, let me hide some details, and I would like to say, notice that we are introducing how to learn the causal diagram from the data, right? So if you can try to link each of the node to each of the specific data set, then in practice we have some statistical tools to test the statistical dependence and statistical independence. So that is exactly we got a sense about the conditional independence, because you can try to see how we can combine these two perspectives together. One is from the graphical side, and the other is from the data side, or specifically the probability side. Okay, so given three of these diagrams, which we cannot further determine their direction, let's summarize it into a new diagram where we replace the arrow here as the line, a undirect line, because we couldn't determine the direction. And we give this model a name, that is the Markovian equivalent models. And let me make a point here. That is, although the Markovian property give us a sense to find out some causal significance from the data, but there is a limitation. The limitation is when we are approached that step, we just couldn't go deeper because there's no idea for us to further determine the direction for a diagram. Just as we have already seen in the story, I'm a plumber and I'm working outside the pipe. I'm working on the surface on the pipe. So there's no any other tools for me to further check out the the flow of the water. I couldn't do something like take apart a pipe and see what the hell's happening in the blowing, right? Okay, so another point is, did you remember the collider I introduced in the previous slide? And here we can just link it into a etymology, which we often call it the V structure. And similarly, I didn't show too many details here, but the sense is, if in a diagram you control the structure like this, you control the node here, then you might raise some warning from the statistical perspective. Okay, so this is one of example to talk about the Markovian property. And in the following, I'm going to use another example. Let's learn more about the causal Markov framework.